Well, good evening. While I'm waiting for parts to come through for my 5200A so that I can get it up and working, thought I'd take a little video of one of the of checking out a piece of kit that's been sitting on my shelf to be repaired for quite some time, and I haven't quite gotten around to it yet. This is a Hewlett-Packard 331A Distortion Analyzer. In fact, they call this thing sort of the mother of all spectrum analyzers. And if I was to actually remove that little box that's holding it up there, you'll see that on the top of the machine, let me see if I can get the light out of the way there. Let's see if we'll zoom in a little bit. You'll actually see that it's referred to as a spectrum analyzer by HP itself, or as we used to say in the military, analyzer, spectrum. You know, cups, canteen. You know, smock, psychological. So this is is really it. This is the granddaddy of all of the spectrum analyzers that everyone has used. So let's tilt this back in, and I'm still trying to, again, apologies for the bouncing around and stuff. I'm still, firstly, I'm trying to work out how to best shoot with the gear I've got here, and I think I really need some additional lighting so I can get some nice light on the front of the panel here. And secondly, I think I need to try and work out where to position the camera properly so that I can get the best sort of video of it, but still have access to the units. Anyway, let's take a look at the basic concept of the unit here. The way the distortion analyzer, well, actually, the distortion analyzer is really two units or two devices in one. This is the 331A, so it doesn't have any RF aspect to it, but it's basically an Rms voltmeter, and then it's the distortion analyzer. So what I can come in and do is I can use this to set a level or have a look at a level of a signal, and I can feed the signal in here, and it, like most gear at the time, came with balanced and unbalanced inputs, and part of that was from the fact that it just, you know, around the early days of ham radio, they had worked out that the impedance of two lines a certain distance apart was like 600 ohms, and they had a bunch of stuff that wasn't tied to ground and all this sort of thing, and so there was a lot of like different types of things. So this came with that ability to take 50 ohm or 600 ohm balanced, unbalanced signal in it. So, what I could do is I could go get a signal and feed it in and read on the voltmeter the value of the signal. And then what I can do is I can manipulate the rest of the unit here to go and give me the distortion, or the total distortion that it's reading out of that signal. And so the way you would do that is you would set the unit up, and then you would tune in. And basically, this big tuner here is a big notch filter. And what you want to do is you want to take that filter and put it right over the top of the fundamental of the signal that you're feeding in. And then if you can get rid of that fundamental, then all of the rest of the signal that you read in has to be distortion and noise from all the different fundamentals that, all the different harmonics that you'll read on the signal. So that's basically the concept, and because this is a manual version, the later versions, the 333 and the 334, eventually had an automatic system that you could turn on that would help you lock in at very low levels. There's a lot of backing and forwards here, and I haven't tried out this unit yet. I bought it to help me replicate the performance test environment for some other old gear that I had, and I never got around to doing that work, and so this has sat on the bench, or sat on the shelf since then. So let's power this thing up and have a look at how it sits there. Let me grab a little. Oh, well, it's bouncing around a little bit that you wouldn't expect. Yeah. So you're supposed to turn these on and then turn them off and give the capacitors, you know, a little bit of time to discharge, and you can see the meter is slowly falling down, and then, you know, you can come in and just do a mechanical adjustment of the zero so that it's just on the other side of the zero there. Okay, so we now adjusted in for our zero. What I have is I have my signal generator set. Now these things, the frequency of this, I think, you know, only goes up to 600K. So I'm utilizing my little Rigol arbitrary waveform generator here. And so I'm going to feed it into a 50 ohm load so that we can set it directly. And I'm just going to drop that in there. And let me set, I've got 3 volts set on there. And if we look, you'll see that I've got it set at 10 volts. And I'm reading close to 3 volts. You know, and if I go to 3, you know, I'm reading 2.9 volts. So clearly off the bat, what I need to do is go in and calibrate or go through the adjustment procedure to get the RMS voltmeter working correctly. Now that I've got that, let's just assume that I was in fact putting in, you know, the right voltage here. What I would want to do now is to go and set the level and go through and set it up, and then start measuring the distortion. So let me just duck away for a sec, and then we will go do that and see how it works. Okay, so now that I'm back, you know, let's go and see if we can get a distortion reading on this. And so what I'm going to go do now is I'm going to go set level and set the sensitivity to minimum, turn the sensitivity Verner down. This confuses the crap out of me, and I get it wrong all the time. Coarse here is marked in red, and it's referring to the center part of this double ganged potentiometer, and the fine is referring to the black part. And so I always screw this up, but basically what we have to do is go to the center of those, and we're sort of horribly misaligned there. Well, that's roughly the center, I think, for both of them. And I know it's going to be 3 volts, but let's set it up to 10 just to sorry, let's set it to set level. Okay, and now I can apply my signal. Okay, now what I need to do is I need to play around with the sensitivity settings until I can read a full-scale deflection. Now, let me see if I can zoom in, and we'll take a quick look at the meter. Alright, so this is the meter, and this is quite common of HP gear at the time. Because the meter basically just simply responds to a certain amount of current to go back and forwards, they would often label different parts of the meter to enable you to do different readings. And so down the bottom here, what I'm reading is, I'm reading the RMS voltage, and you know, that the scales tend to go, you know, power of 10, so 1, 10, 100, so on, and then the intervening scale tends to be 3, 30, 300, that sort of thing. And so on the top side of the scale you'll see the 0 to 1, and on the bottom of the side of the scale you'll see 0 to 3. And you read based on which one of those which one of those values, the 1 or the 3 value, off the top or the bottom of the meter. Now, across the top of the meter here, you've got a dB calibrated basically for decibels. So if I was going to do a distortion value, and commonly, you know, when you look at distortion and things, you'll look at it compared to a carrier frequency or a center frequency, you know, and so you'll have like a dBc or a decibels off carrier or decibels off center value. And I could go and do this as a decibel item, but what I'm going to do instead, and let me just see if I can capture that by zooming out a little bit, is now that I've set my level here, what I want to do is go in and set my sensitivity so that I get greater than, it says, 1/3 of the scale. So that's certainly greater than 1/3 of the scale. That's getting pretty close, but it says 1/3 of the scale. I guess I can, you know, play with the vernier to get it there. No, we want to say, let's go up this way and then come back down here. So that's so we're over 1/3 of the scale there. So now I'm ready to go and start checking for distortion. So let me zoom back out a bit further and refocus the camera on the whole thing, and you can see the back and forward. Alright, so here we go, you've got the whole set up. So now let's flip that over to distortion. And now what we're supposed to do is to play with the range switch here, the balance, and the frequency dial, because remember, with the frequency dial we want to get that notch filter right over the top of the carrier. And so what we're going to try and do is find the lowest point on the meter here. So let me start doing that, and I'm going to keep winding that in, and that's about as low as it's going to get there. And now I could screw around with the balance and everything, but I think we've probably got a little bit further to go just based off the signal. So let's see if we can get any further down. No. Alright, so now what I have to do is now start playing with this balance control to try and get, and so start with the coarse and see if I can, you know, get it to bottom out. And it's gonna bottom out very close to 0, so let's step down again. Let's keep playing around with that. Let's step down again. That's it. Give me a bit more range. We'll step down again. Oh, okay. Let's step back up. Let's see. Alright, well, that's an item that's going to need to be repaired. You saw what happened there with, you know, these potentiometers get dirty, and, you know, they jump around and the carbon wears off, and so on. And so you saw that this guy sort of stopped, you know, once I started getting down around there, it's very noisy. And so if I come down again, now maybe I can try with the no. Let's see if I can. So I think that's getting close. So this is telling me, you know, I think I need to work on this this potentiometer here. But what I'm reading from this is, because if we look down here, you'll see that I'm on the, in terms of the level, I'm on, I'm on the 1% level, so it took me a little bit while to work around that. So the set level, because you can set for percentage or decibel, you know, I want the 100 line up here, and that's going across here. So it's the 30, the 10, the 3, 1, 3, blah. Had I been setting my level on the dB scale, I'd want the 0 level set, and then I would be dBs above and below sort of 0 item there. And then that intermediate blue scale was for the voltmeter. So I don't think I can get, so like, you know, what I'm going to be doing is just buggerizing around now based on the amount of, and you can see if I wiggle it, you know, we're getting, it's jumping around and that. So what we're seeing there is on that, we're on the 1 scale, so that's the top one. I'm seeing, you know, I'm seeing 0.14 of the 1 scale, so I'm reading, you know, 0.14% distortion on that signal. That's coming off that unit. That's very, very high, and I suspect that there's noise coming out of this here that's stopping us from stepping down a little further. Anyway, let's bring in something a little bit more modern and take a look at that. Alright, so what we have here is my Keithley 2015 Thd meter. Now, I bought this actually not because of the Thd aspect to it, but because at the time somebody dumped a metric arseload of these meters onto the market, and so for a 6.5 digit volt and ohm meter that does 4-wire ohms, these things were incredibly cheap. And so I was like, okay, great, you know, I'll just going to buy a 6.5 digit meter. But it has, as part of this, it's actually designed to also do total harmonic distortion measurements across the audio spectrum. So let's turn this puppy on. And now we're going to go, now that's on, let's set the measurement. You know, we want it to be THD. The frequency, well, this, you can set the frequency that it expects. I know it's 1 kilohertz, but I'm going to leave it on auto, and this will basically sample the frequency first before it does the rest of its calculations. So, you know, I want to get, let's get all 12, let's get 12 of the harmonics, and let's have that come in percent, and I don't want any filters. Okay, so now let's plug the signal in. Let's just bring up volts AC, and you'll see that what I'm getting off my signal generator is 3 volts RMS. I'm reading 2.98 here. Anyway, let's go in and have a look at that percentage distortion. So you can see we're pretty much a long way off in terms of the distortion difference from the signal based on the 331A. And I wished I had an actual known distortion signal here. I'm sure I can create one with my signal generators, I just don't know how. If you do know how, please tell me in the comments. I got to go do the look up on that, because normally you're not trying to put known distortion in things. But I'm coming out, you know, about 0.01% distortion. That's roughly in line with what the specs of my signal generator are. So it was pretty good at the time, but I think we need to do a bit of a repair on that potentiometer, and then maybe try again. Fix up the voltmeter, see how we go, if we can calibrate that in. Anyway, I hope you found this interesting, and I'll do another video on opening up this 331A and having a look what's inside it and doing that calibration. Catch you later. Bye.